This video discusses how to set up your workstation or PC and configure Brocade SAN for use with the FOS RESTConf API with an introduction to sample scripts and libraries. Our legal disclaimer is here for you to read. Comments, questions, and feedback are always appreciated, and I'm available for consulting. This is the Getting Started video, so let's get started by installing Python. Here is the link to download Python. The minimum supported version is 3.7. I ran into some issues with older versions of pip, so I recommend upgrading. The shortcut py is assumed to be configured in all examples in this series. If not, you will need to type out Python or Python 3. I'm only going to illustrate how to download the supplemental documentation. In addition to the user documentation, the supplemental documentation includes tips and details for developers. Use the same process to download the other folders. We'll talk about what to do with them on the next slide. The last slide of this presentation illustrates how the FOS-specific libraries help simplify programming tasks. The difference between the examples and the applications is subtle and probably only significant to developers. I expect most people will just lump all these contents of these folders into the same folder along with the documentation. So a PyPy package for the libraries was a work in progress when I created this video. For now, you're going to have to copy them into your lib folder or any folder with path access. Unix users will need to make sure the execute attribute is set for all of the files. All of the folders must have write access, and this is because Python wants to put a folder called PyCache and of course some data into that folder. This is a cache that Python uses. Access to the libraries is the most common issue I help people with. Run libcheck to determine the library paths and to see which libraries need to be updated. The output should be self-explanatory. I'm assuming everybody's going to recognize their local path. The standard Python lib folder is going to be something like Python/Python version/lib. The libcheck utility can be found in the Brocade REST API applications folder. The last time I installed Python, these were Python and open source libraries I needed to add. Your installation may be a little different. This is why I recommend running the libcheck first. If you need a standard library or open source library, the procedure to install them all is the same. Simply copy and paste each pip install command you need into a shell or command prompt. At the beginning of each sample script are two comment lines. The first line is referred to as the shebang line. This should be in any script you write, especially for non-Windows environments. The second is rarely used because UTF-8 is the default character encoding for all operating systems except for ZOS and OS 400. Since these scripts are supported on those operating systems, I explicitly added the encoding line as well. These comment lines are in the sample scripts, both in the applications and examples only. The library files do not need those and should not be edited. Windows users shouldn't need to make any changes. Typically Unix variants, Mac OS, ZOS, and OS 400 use the local space. Check with your system admin. If you don't have a system admin and you're not sure what to do, just do the recommended edits I have here. All of the sample scripts must have the correct shebang line encoding comments. Use VI, Notepad, or any plain text editor to make the changes. This concludes everything I think you need to know about installing and configuring your PC or your workstation for Python. Now we need to talk about what you need to do with your Brocade switches. I'm assuming everyone wants to use HTTPS with a self-signed certificate. Depending on the version of FOS you are using, HTTP may not even be allowed. Certificate from a CA is not discussed in this video. The first thing you need to do is check to see if your switches are configured for a self-signed certificate. From an SSH system with the management interface, just type that circ management show-all command. Scroll down to the certificate files section. That'll be a little lower in the output. Look for the private key column in the HTTPS row. In this example, HTTPS has already been configured with a private key. I know this because exists is in the cell. There is no need to do anything else. If this is empty, you need to create a certificate. Okay, only do this if you need to create a certificate. In other words, that previous cell said empty. Simply copy and paste this command into an SSH session or command prompt. Of course, it's a good idea to go back to the previous slide and validate that the certificate was in fact created. Unless you plan on allowing multiple REST sessions to access the switch at the same time, just copy and paste these commands into an SSH session with the switch management interface and move on. Few people need to make any changes to these settings. There is a detailed explanation of throttling in these settings in the supplemental documentation, as well as the Brocade REST API guide. And there's some additional details if you really want to know what this stuff is going on, just in these handout notes right here. Now, use this command to validate the settings made on the previous slide. You could also use appconfig.py and the Brocade REST API examples to check these settings. You could also make changes with the appconfig.py module as well. Of course, you can't use an API script to enable the API if it's disabled. I'm assuming most people will make these changes and validate them via an SSH session. But the reason I'm putting this discussion in here is because developers will need to disable the keep alive when they're setting breakpoints. I have a batch file I run that includes appconfig.py to disable the keep alive before I begin any development work, and another batch file that re-enables it when I'm done. I'm assuming most developers are going to do something similar. The login test script attempts to log in and log out. It doesn't do anything else. To do this, it needs access to the driver library, and it also needs access to the switch. So running this test, therefore, validates access to the Brocade API driver library, validates that the network is configured properly, and validates that the switch is configured properly for API access. For most environments, you will need to hard set the IP address on your PC or workstation to be a unique IP address on the same subnet as the switches. A web search should return several results on how to do that. If your organization has a network admin, check with your network admin first. Once you get past this test, everything else should be smooth sailing. So not as to have to repeat discussing the common sample script inputs with each sample script video, I'm going to cover them now. Logging credentials are supported on all scripts that need access to a chassis. HTTPS is the default, so I don't expect anyone to ever use the -S option. -D is not normally used. It is supported on all modules that access the chassis and a few others. All data structures sent to and received from the chassis are printed in human readable format to the log. The -log option, all scripts create a log file named log_timestamp. The timestamp is down to milliseconds to ensure all log files have a unique name. By default, they are placed in the folder where you are run the script from. The -log option allows you to specify a folder to put them in. That way, you don't clutter up your folder full of log files. The -NL option stands for no log. It allows you to tell the script to not create a log file, although messages will still be printed to the console. -SUP, that's for suppress, and that suppresses printing of all messages to the console. That's usually useful for some batch processing. -scan, I'm going to show you a sample output on the next screen. This is supported with most scripts that read a captured data file. And that captured data file we're going to discuss more in the module that covers capture and report data. This option allows you to interrogate those files. No other processing takes place. The -EH option, that's prints extended help information to the log into the console. It is supported with scripts that have complex input. No other processing occurs when you use that option. -H, that prints basic help information for the inputs as well as a module description. And again, no other processing takes place. Chassis, switch, and fabric names do not have to be unique, so for scripts that require it, they are identified by their worldwide name. Each logical switch in each chassis is listed with the fabric and logical switch it is a member of and the zone configuration defined for that fabric. This is a high-level overview of the architecture. Starting from the bottom, the Brocade API library is a traditional driver with some value-added functions. The Brocade library is a hierarchical relational database. The Brocade REST API examples only use the driver. They were originally intended as examples for developers, but some were useful as standalone utilities, so I added a command line front end to them. The Brocade REST API applications rely heavily on the Brocade DB library and are discussed in greater detail in the other YouTube videos in this series. There are two types of applications. Some take a two-step approach whereby data is captured and written to a file using the script, and then another script reads that file and does something with that data. That's typical of like reports. But this is why there is a -scan option with some of the scripts. Some of the scripts, they combine both these steps in one script, so there's no reading and writing of files, and then yet there are some other scripts that are a hybrid of these two. The best way to explain how these libraries simplify coding tasks is with an example. Let's say I'm going to migrate off of a storage array. I'm going to want to know what servers are talking to it. I want to know where it's connected to the SAN. So I have a library here that logs in, gives me a session object. I then have this get batch utility that goes out, captures all of that data, creates objects as necessary, attaches whatever data I captured from the switch to those appropriate objects. I'm then going to spin through every fabric object that I just discovered in the previous line. This alias list of aliases, I have this utility alias by name. It takes an alias, and in this case I used a wildcard. It also supports regex matching. So now I have a list of aliases, and presumably you use an alias naming convention that makes it easy to identify your storage array. I need objects though. This is just a list of aliases by name. So this next line of code just converts all those aliases, gets all the alias objects. I'm going to need a list of port objects. So this object extract utility, what it does is it takes a list of objects and it converts it to whatever I tell it to, in this case port objects. And it removes duplicates, so if I had MPIV technology here with duplicate role by names, I wouldn't get duplicate objects. The zone object list uses the same utility, only this time I'm extracting all the zone objects. And the reason I'm doing this is I need to know what servers are talking to that storage. I build this all alias object list by, again, using that same utility, only this time I'm extracting the alias objects out of the zone. Now, I would normally subtract out the storage aliases because what I really want is a list of server aliases, but this is good enough for this example. For the cable teams, I'm probably going to want to give them a workbook. So I have a utility to give me a workbook object. I have a standard utility to insert port pages into that workbook. I save the workbook, and that's it. I'm done. Thank you for watching.